And so welcome everybody to the webinar. We're going to be looking at how to handle dynamic content with Applitools Eyes. It's going to be a very technical focused webinar today. We're going to go through three interesting cases where we're going to look at dynamic content such as tables, product grids, and then like changing dashboards and stuff like that. And we're going to look at the tools that are available to you offered by Applitools Eyes to handle this type of content gracefully. And as I'm sure as practitioners, you guys are all aware that this can be a problematic and a hard thing to handle sometimes, and you have to set up certain things to make sure that it works correctly and that your tests aren't flaky. And Applitools has tools built right into it that come out of the box for making these cases easy to handle. So I'm going to go ahead and jump right in and share my screen, and we're going to jump into our first example, which is going to be a dashboard for a financial application. And this is the application we're going to be looking at first. And if you notice, we have a few balances here at the top, along with a table down here. And if you'll notice, every time we refresh, as with any financial application, we get a lot of updates. The balances change, the data is live. You'll notice that we also have changing values down here in the table in the bottom right. And so this is a tricky page to test because of all the moving parts here. And we have to devise a strategy to understand how this, to make sure that this test is not flaky every time that we run it. So to jump right into the first example, I've set up a very simple Cypress automation test here. For those familiar with Cypress, this will look very simple. But for those not familiar with Cypress, I'm just going to go over kind of what's happening here. The first thing we do is make our call to Eyes Open. This is the Applitools SDK function call that kind of kicks off the automation test and sets up the communication with the Applitools server. You can see here we're passing in the name of our application, as well as the test name that we're going to be performing. In this case, we're looking at a bank, and we're going to be looking at match level regions, which is a little hint of what we're going to be doing later on. And then also we're setting up our ultra-fast grid configuration. For those who are not familiar with the ultra-fast grid, it is a cross-browser testing platform offered by Applitools, which allows you to easily scale cross-browser tests simply by configuring the browsers and environments that you want to run tests against in the configuration of your code. You can see here I've commented out a few other environments. For simplicity today, I'm just going to be only running on Firefox with this width and height. But you can see here if we wanted to scale to other browsers and even mobile devices, it's very trivial to do so. If you want to learn more about the ultrafast grid, I've put a link to the documentation on how the ultrafast grid works and how you can use it in your tests as a resource. You can find resources in one of the tabs near the chat on the right side of your screen. So like I said, that's not the main focus for today, so just going to be doing the one browser for today, but just wanted to call that out. So in our actual test case here, we are visiting the website that I showed you previously, that dashboard, and then we're just simply taking a visual AI screenshot, and we're going to see the results that we get. So let's go ahead and run this test for the first time. And once we run this test, we'll head over to the Applitools dashboard, and we'll just take a look at what the results are, where we're not doing anything special. We're just kind of taking the capture, and then we're not handling the dynamic content at all. So we would expect this test to come back as unresolved with a failure. But let's go ahead and see what comes in as this wraps up. And as expected, we can see we get a test status of unresolved. So for those who are not familiar with the test status unresolved, what this means is that we did a visual AI comparison between a baseline image and a checkpoint image. The baseline image is on the left side of the screen, and the checkpoint image is on the right side of the screen. And if we zoom in closer, we can take a look and see how, okay, so these balances are different because as we saw, every time the page loads, the content changes slightly, as well as the balances down here are different. And this is going to change every single time that we load this page. And so it's not something that we can just say, hey, these are expected changes and move on, because it's going to fail our tests every time we run this pipeline. We need to handle this gracefully. Like those familiar with Applitools will know that if you see something like this, a difference, you would either usually approve or reject the differences as an expected change or an unexpected change or a visual bug. But in this case, we just need to refine our tests because there's no visual bugs here, but we're getting a flaky failure. And so what can we do to handle this type of stuff? If you've used other visual testing tools before, you might be inclined to use sort of like a pixel threshold or even ignoring these regions altogether to kind of just make sure that your tests aren't flaky. But that sacrifices a lot of test coverage and leaves you vulnerable to visual bugs entering into your application and not giving you the 100% test coverage that you need to ship with confidence. And so what we should do instead is use the Applitools Visual AI match levels. So a visual AI match level is an AI algorithm that's been trained to compare a baseline image to a checkpoint image. And by default, the algorithm that we've chosen is strict. This is the bread and butter of Applitools. And what this means is that everything that is detectable to the human eye that is different between the baseline image and the checkpoint image is going to be picked up by the visual AI and flagged as a difference. And as we can see, that's exactly what happened here. It's doing its job. It's saying, hey, these balances are changing. But for our purposes, we need something that not only validates that the page looks correct, but is also smart enough to understand that these balances are going to change, things are going to be different, but that's okay. That's an expectation. And so one of the other algorithms that we have to offer is the layout algorithm. And so the layout algorithm works in a way such that it doesn't really care what the content of the page is, in the sense that it won't care that the left side of the screen says 8,000 versus the right side of the screen says 25,000. All it cares about is that there's a balance that's present there and that its relative positioning to the rest of the page is consistent. So let's go ahead and see what happens if we change to layout to compare these two images. So I'm going to click here, and it's going to rerun the algorithm, and we're going to get a new comparison. And as we can see, our differences are gone. We no longer have any pink highlights, and we can see that this test, if we had ran it with the layout match level, would have passed. Now this is great, but the problem is that we don't necessarily want to apply the layout region to every single part of this page. We don't want to have it globally applied to things like this sidebar over here, where we want to make sure that this sidebar shows the credit cards label specifically or the debit cards label specifically. We want to show the name of the application in the top left. We want to make sure that that doesn't get changed unexpectedly and things of that nature. And so this is where we need to come into a combination of the strict algorithm, which is perfect for maximum coverage and making sure that everything looks correct to the human eyes, and layout coverage, which makes sure that, hey, like the content that we're looking at, it can change, and that's okay. So let's change it back to strict, and let's explore what else we can do. So it sounds like we need to apply layout region only to the specific, or layout match level to only specific parts of this page. And so what we can do is use regions. Regions are specific areas of a test result that you can apply a different algorithm to in order to handle different cases. You can see we have regions for a lot of different things. We'll go over some of these other ones later, but for right now, let's take a layout region and wrap it around our dynamic content. And you can see here, when we do that, we're now getting the best of both worlds, in the sense that we are applying the layout algorithm to the changing content and removing our differences, but we're also applying the strict algorithm to the rest of our screen, which gives us the maximum coverage that we need for this test result. Now, the problem here is that we don't want to come in after every single test run and draw these regions, because imagine if we were running at scale on a bunch of different browsers, on a bunch of different environments. We don't necessarily want to come in and draw these regions manually, because the size can change. Like, let's say the padding between these balances was updated by an engineer, and like we would need to redraw our region. So let's not do this manually. Let's go back to the code, and let's apply these regions dynamically using a CSS selector. So we can come back to our code configuration, and in the call to eyes check window, we can configure the visual AI snapshot to apply layout regions to specific sections of the page. And I've grabbed the selectors for the two elements that we just saw that I drew boxes around manually, and I've placed them into the call to eyes check window. And let's go ahead and run this test once again and see if our test passes as expected. Okay, just waiting for this to come in. And as we can see, this time our test passed as expected because we used the layout regions, and we have our dynamic regions placed around these two sections of the page that we were talking about earlier that had changing content. And so now when we run this test going forward, no matter what these balances change to, we're going to be okay, and we're going to get coverage, and we're not going to get a flaky test. And you might be saying, well, wouldn't this behavior be the same as you say like an ignore region, or a pixel width or threshold? And the great thing about the layout algorithm is that you're still going to get visual coverage for bugs. Like, let's say one of these balances didn't load correctly, or one of these table rows didn't load correctly, or something along those lines. The layout algorithm is smart enough to know when there's a structural change to the program, and it will still flag problems that you might not expect to occur. So you're covering yourself from unexpected bugs while still making sure that the expected changes don't fail your tests. In fact, we can take a look at this really quick. And to show you the power of the layout region and the layout algorithm, let's simulate something changing on the page. So for example, I'm going to remove one of the balances to simulate that it didn't load correctly, or something happened where it didn't render on the page as expected, right? And this is a element that is within our layout region. This element is this element right here, this middle balance, the credit available balance. So let's see what happens when that gets removed while we still have our layout algorithm running in that section. Okay, and we'll wait for this to wrap up. Doing the visual comparison. And as expected, as I mentioned earlier, layout is a lot more powerful than just ignoring a section altogether just because it has changing content. It's actually validating and looking at the page and looking at the structure of the page and understanding that before there were 3 elements in this section here. There were 3 different balances. Now there's only 2. This is a problem, and it needs to be flagged. And the QA engineers or the engineering team needs to be aware that something is not loading as expected. And so this just kind of shows that beyond ignoring, layout is able to tap into more and more coverage than you would expect from just a simple, trivial, pixel to pixel comparison, and then ignoring the content altogether. Because then you just leave yourself vulnerable to bugs like this. If you just ignored this section, you would have shipped this code, the test would have passed, and you'd have a big bug in your production website where a balance doesn't even load for your bank app, which is a big problem. So I want to pause here for any questions. If anyone has any questions in the chat, feel free to send them in. If not, we will move into the next example that I have prepared. Okay, looks good. Let's go ahead and move on to the next example. So scenario 2, we're going to be looking at a slightly different application. We're going to be looking at an e-commerce application. It's similar in the sense that it has a dynamic feature about it. For anyone who's worked on e-commerce websites, testing e-commerce websites, I'm sure you know how products change, prices change, pictures of products change. There's a lot of moving parts when it comes to e-commerce or anything like that. And so here we have a product grid. You can see we have different prices, and these products are subject to change at any time. At any point, one of them could be removed. At any point, the pricing could change and all that stuff. And so there's a lot of different products that are offered. And so managing this without AI would be a pain, because you'd either need to set up some sort of other environment that kind of hard codes everything, which kind of removes the spirit of actually testing the application, in its raw form, or you'd need to spend time like ignoring things and going through and making sure that everything related to these specific sections is handled, and it just results in a lot of maintenance for the QA engineers, which wastes your valuable time. And so this is why using AI can make things like this a breeze. So let's go back to our code really quick, and it's going to be a very similar setup. We're calling eyes open, different app name, different test name, running on one environment for now. just for simplicity. And we're going to the e-commerce website. And then I'm going to do a similar thing here where I'm going to mimic a product being removed from the catalog. And so we're just going to remove one of the products, kind of hard-coded here. But again, you get the sense that imagine that the API endpoint that we're hitting, the backend changes, the Shopify account changes, there's no longer offering a product, and the grid will change. Everything will shift, and there'll be a completely different product grid being shown. So now let's go ahead and run this test and see what our results look like. Okay, let this wrap up. And I've already created the baselines for these tests. Normally, the first time you run a test, you'll get a new baseline. I'm sure anyone who's worked with Applitools before is familiar with that workflow. I've set up these baselines already, so we're jumping right into the comparison side of things. And so as we can see, let me make this a little bit bigger, and we'll split this off. As we can see, we're getting a lot of differences here. And let's remove them for now so we can really see what happened. And if you'll notice, as I toggle between the baseline and the checkpoint image, you'll notice that we removed this product right here. And this caused the rest of the grid to shift up, and all the images are different, all of the, everything's different, which is why everything is pink, and strict is doing its job once again. And so in this scenario, let's see what happens if we apply a similar layout region to this section. Let's see if we can just draw a layout region, and we're going to do it from the code again. Let's see if we can draw a layout region around our product grid and see if this will handle it gracefully, just like it did with the other application that we looked at first. So just like before, we're going to add this layout region to our configuration of Eyes Check window. We kick off this run here. And this selector down here is covering the entirety of that product grid. So if it changes in size, length, whatever, it's going to just dynamically fit the size of the grid and apply the layout region to it. And we'll see if we get a similar result to before with the bank app. And it'll be interesting to see what the results end up being. I would assume that the layout region would cover it because it handled it so gracefully before on the other application, but this one is a little bit more complex, so we might see something a little bit different. And as I mentioned, so first of all, you can notice that right away, there's a lot less differences. Like, it's already figured out that, hey, even though the products shifted, even though the products are all different from here all the way down through the rest of the grid, it's already figured out that, hey, that's okay. Layout's doing its job in that sense, where it's saying it's all products, it's all photos, it's all, a name of the product and then a price. Like, I got it. I got that concept. We can handle that. Oh, and yeah, just to answer your question, there will be a recording of this webinar. So we will send that out to everyone who's attended it. And everyone who registered as well will get a recording as well. So if you know someone who wasn't able to attend, they will get the recording too. Okay, so just jumping back to this, you can see here that the pink differences are drastically less in this case because layout is doing its job for the majority of the grid. But as we saw earlier, layout does flag when things are missing. In the previous case, when something was missing, that was good. We wanted to be notified when a balance didn't show up on our bank dashboard because that's a critical part of our application. So we were okay to kind of just leave things as is. In this case, we don't necessarily want to know when there's an empty space when we compare it to the previous version of our application because there's going to be a lot of empty spaces. Can I use layout to examine a node is missing from a tree? I would have to look at the specific example, but in general, yes, you should be able to use layout when something is missing from a tree. If you're looking at like a tree that's like dynamic or that's static and you want to make sure that something is not missing, then I would recommend the strict algorithm. But if the tree is dynamic and you wanted to just check for a specific node, layout should definitely work for that scenario. But again, we'd have to look at the specific scenario. But it is designed to handle dynamic content in that sense. So just finishing up here, as we can see, similar to the first example, we have something missing, and layout is letting us know that something is missing. But in this case, we don't want to be notified when something is missing. We just want to we want the grid to be what the grid is, and as long as the grid itself is present on the web page, like as long as this element that has all the products is present, we want the test to pass. So what we can do is we can offer certain enhancements to the layout algorithm. And by enhancements, I mean a couple of flags that we can add as arguments to our cy.eyes check window function. And these two arguments are enable patterns and use DOM. So the way the layout algorithm works currently, before we add these enhancements, is it's looking at the baseline image, and then it's looking at the checkpoint image. It's using AI to compare those two, and it understands the structure of the two pages strictly based on the images themselves. It's not using any other context behind the scenes. It's not using like any sort of DOM or anything like that, metadata, to enhance the learning of it. It's just recognizing patterns as an AI algorithm and then applying what it thinks is the best result to that comparison. So what we can do with these two flags is we can add in more context, we can add in more metadata to make the layout algorithm even more powerful and more understanding of what's really going on with the page. The first one, enable patterns, will add another layer on top of the analysis that it does, where it will look for specific patterns on the page, things like a grid, things like a table with repeating rows and stuff like that. It'll kind of just look for something that is repeatable, and then it'll understand that that should be extended. The second one, use DOM, is pretty self-explanatory in the sense that it'll take the DOM of the web page that's uploaded to the Applitools servers, and it'll use that in the comparison as well. So it'll look for table elements, it'll look for grid repeating elements and stuff like that, and it'll use that to make sure that it even more like further understands what's actually happening on the web page. And so just setting these to true kind of levels up the layout region to another level. The reason you might think, oh, like why wouldn't we ever put this? Why wouldn't we put this on every single test that we run? And the reason is performance. You won't notice a difference from the test that I'm about to run versus the test that I'm running. In fact, I'm just going to kick this off while I'm talking. In the test that I ran before, you won't notice a difference in like the time that it takes. It's going to be very minuscule. But imagine if you're running at scale, you don't necessarily want to have all that extra work running behind the scenes. You really only want to apply these enhancements to the specific use cases that you're trying to cover for particularly complex screens that you're trying to analyze. And so, long story short, let's see if these enhancements provide the layout algorithm with the metadata that it needs to perform or to better understand this product grid and ensure that even if something is missing from the product grid, we don't get a difference. And as we can see, just from adding those flags, we get a clean result. And it's the same situation where we have the product that's missing. This product up here gets removed, and we have the white space down here. But unlike last time, now that layout has all that extra metadata and context that it is aware of on the page, it's more able to understand what is happening, that we have a product grid, these things are repeatable, and that this result right here is okay because this is expected. And so this is, again, the power of the layout algorithm. It's very smart. It's able to make inferences and understand what is happening on the page. And we can also enhance it with these flags to handle dynamic content, in a more powerful way. Okay, I see a follow-up on this. Use the table as an example. If the table size is changed or size of the cell is different, can I ignore? But if the cell that's missing, test should fail. Yes, well, that's actually a great segue into the final example that I'm about to go over, which we're going to go back to our bank dashboard, and we're going to look at that table a little bit more closely, and we're going to see what happens when an extra row is added, when the cells get shifted because the content changes such that the cells are different widths. And so that's a very complex situation where if you have changing tables, and matter of fact, let's just jump over to that right now. Thank you for that question. Great segue. Let's jump over to that right now. And we'll go back to, let me pull up the URL directly. We'll go back to the bank app, and we'll go to the dashboard, and let's configure this to extra table row. So we're going to add extra row to this table. So you can see here, we added this row to our bank table. And with that, let me just toggle this off, you can pay attention to the columns here. You can see how they shift, right? So the columns are different sizes because the row that we're adding in is changing, because now the column shifted to the left slightly. This one got bigger because this content is much larger than anything that was there before. And so it kind of caused everything to shift. This is a very difficult scenario to test when you're not using something like visual AI or something like the layout algorithm that's smart enough to understand what's really going on here, because there's so many moving parts. It's not just an extra row. It's not just a changing string. It's like the content is completely changing its width, and it's dynamic, and it can happen at any point. So let's jump into the third scenario where we're going to try to test this specific table gracefully. So now we're going to go over to the third example that I have prepared. And this is very similar to the first one. It's going to be this. We're going to compare it to the same baseline because we have the same app name, the same test name, and our environment is the same, the Firefox environment. And in this case, we're going to already have our layout regions assigned to the regions that we had earlier, so we can pick up kind of where we left off. But let's go ahead and run this test, the third scenario, and see what the results are. And we can kind of go and look. So the other thing I want to call out is that previously I applied the layout region. So if you'll notice from the earlier example here from the bank one, we applied the layout region to the full table, right? That included the headers, right? So we just kind of did it there. But this isn't the best scenario because we don't necessarily want to ignore changes in the headers. Like if this header should change from description to something else, or not ignore, but you know what I mean? We don't want to ignore content changes. We want to confirm that this says description. We want to confirm that this says status. We want to make sure that the layout algorithm isn't ignoring those content changes that are occurring. And so the other change that I made in this last scenario is I changed the selector to just be for the table body. So if we go to look at the new test that I just ran, which is coming back as unresolved, we'll notice that let me zoom in on this to make this really clear. So I'll take the differences off for now, but if I toggle between the baseline and the checkpoint, you'll notice that these headers are sliding back and forth. And now that our layout region is not covering them, we're getting differences flagged because they're shifting side to side, right? And then the other thing is that the layout algorithm, without the enhancements, without any of the bells and whistles that I talked about in the second example, the layout algorithm is now throwing differences because of all this shifting content. So it wasn't just the raw layout algorithm itself was not able to kind of discern what's happening here. And it's throwing differences within the table itself because we're getting not only a vertical shift, but also a horizontal shift. It's a very complex situation. So now we'll handle these headers second. Let's first get this table back in working order such that we get a passing test result for this specific section of the table. So let's go back and let's do our same enhancements for this test so that we can inject the context of the DOM and also add in that extra step for it to analyze the patterns on the page and see what exactly is happening on this page and understand that the table added another row. You should notice that pattern. You should know that the cells are all table cells and they're all present. You should notice that, this isn't something that should be a difference. And so let's wait for this to wrap up, and then we'll see if layout is able to successfully understand that, given that we've injected the extra context into the algorithm. Okay, and we still get unresolved, but as we notice this time, no differences are thrown in the table. It's able to understand, okay, thank you for giving me that DOM context. Thank you for having me check for patterns. It's able to understand that even though this content shifted both horizontally and vertically with another row, it grew in size and all that stuff, you can see there that there's an extra row at the bottom. It's able to understand, no big deal. I got the concept. There's 5 cells, there's 5 columns, and all the rows are pretty much the same. This table looks good to me. Now we need to handle the issue with the changing table column headers. So this is a tricky one because if you'll notice, the headers are shifting side to side, as I was talking about earlier, because the content in the table grew, or the content in the table changed such that the actual widths of the column are different and dynamic. So if you're working with a table that doesn't have hard-coded widths with each column, which is pretty much always, I mean, there's very few applications that I've seen that are hard coding the widths of the table data, because if you're using a table, for one reason or another in your application, it's because you want to present dynamic data in some way, shape, or form, right? And so assuming that the table cells are going to be the same width every single time is not feasible. And so we get this shift from the description going from left to right. The cells are shifting. And so we can't, like I said earlier, we can't just extend our layout region to cover this, because we don't want to miss a visual bug or a change to one of our columns that's unexpected. Like if this says status, or if the color of the table of the font here changes color such that it's hard to see. We want to capture all of those differences without throwing bugs when our tables changes in width. And so we're going to look at another feature here that Applitools offers for dynamic content like this, in the sense that we want to confirm that this says description, but we also want to ignore slight shifts in content. So what we can do is something called a floating region. A floating region is another type of region, and it consists of two different sections. The first region, which is the inner, let me draw this around again. Hang on here. Just waiting for the algorithm to pick back up. Let me get rid of this. Okay, so we draw the floating region around our specific column header that we want to look at. And so you'll notice that with the floating region, it consists of two different sections. There's an inner section which covers the element that we're worried about. So in this case, it's the description column header. And the outer blue section, it defines what part of the page, or what boundaries can this element live in before we throw a difference. And if you'll notice, the yellow is within the blue. So if we shift this over such that the specific section is outside of the yellow part, we're going to get differences. But if we wrap it around the column specifically, now we're basically saying that this description header can move anywhere in this blue section, and we're not going to get a difference, right? So, but still, if this changed in content, like if description changed to describe or something different, we would still be notified. But if this was moved from side to side, we're not going to get a flaky failure. So this is very powerful in the sense that we can combine kind of like the ability to check for strict differences like color and font changes, but positional changes we're not really worried about. So it's kind of like an in-between type thing between strict and layout, which is super powerful for specific cases like this. So again, we don't want to hard code all of these regions. We want to have this scale nicely with all of our tests. So we're going to do this from the code. So let's go ahead and add floating regions to all of the different sections, all of the column headers on our table here, and see what we get. And so it's a similar API to the layout region, in the sense that we're calling floating, and then we're passing an array of selectors. So we see here, this is the column 1, this is column 2, and et cetera. It goes from there. You can see the nth child, 1, 2, 3, 4, 5. And then the other metadata that we pass into the float API is the offsets. So we can pass offsets going up, down, left, and right. In our case, we don't really want the table columns to be moving up and down, so I'm not putting any offset for vertical movement. If it moves vertically, we kind of want to check that and make sure that positioning of the page is correct. But in this case, we want to allow for slight shifts left and right based on the size of the columns and the table content changing. So let's go ahead and run this. I got to save it. Run this once again, and we'll see what we can get. And yeah, hopefully this will give us a clean coverage for this complex example where there's a lot of moving parts with both horizontal and vertical shifts happening in that table. Okay, we'll wait for this to wrap up. Oh, interesting. We got a difference flag there. That was unexpected. Let me try to run it one more time. In your example, can you still catch an entire row missing? Yes, it would. We would have to configure it in a certain way. I don't have anything set up which can show that right now. But as we saw with the product grid earlier, Yanming, we saw that something was missing and we were able to capture that. And as we saw with the balance earlier, something was missing and we were able to capture that it was missing, right? And so it can capture that something is missing from the table altogether. It's going to be complex. And again, it's a case-by-case basis. These are all tools that are available to you, these floating regions, the layout regions, the strict algorithm, et cetera. And each case that we're looking at, you want to apply kind of a different solution to based on using these tools. So it's hard to say specifically as like a blanket statement, but I have seen, I worked on the technical customer support team at Applitools for 4 years, and I was the manager of that team. And I worked with a lot of different customers and a lot of complex use cases. And for sure, we have covered that use case many times with customers. So I can say that it is possible. I just can't say specifically if the case that you're talking about right now it will work with the solution that I've shown here today. We would need to make sure that we apply more of a tailored approach using these tools, kind of interchangeably. And I hope that makes sense. I know it's like the classic, like, oh, it depends, but that's kind of how it is with a lot of these software tools. And then Christopher, I see your question. Do those selectors work with data CY? Yeah, I'm pretty like the selectors should work with any sort of CSS selector. It also supports XPaths. So if you wanted to do like XPaths with data CY or things like that, any sort of way that you select an element in an automation test, the selectors that we're passing can work. So I hope that answers your question. And if not, feel free to let me know. Okay, so as we talked about earlier, we now have full coverage for this test, and we have the same situation where things are shifting and extra row is being added. There's a lot of moving parts, but we use the tools that are available to us from the Applitools Visual AI, and we're able to handle this case gracefully. So now, running this test over and over again, we don't care if more rows get added. We don't care if more rows get removed. We don't care if things shift left or right. We know that if we get a failure for this test, it's going to be something that we're interested in looking at and reviewing. It's going to be something that we don't have to waste time looking at false failures and things like that and dealing with like data changing, because who wants to go in and look at, oh, this content changed. This isn't a visual bug. Like, I'm just wasting my time. I want to just be able to ship with confidence. So it's a balance between flaky tests and, removing flaky tests, but also keeping the maximum amount of coverage such that, you do get notified for bugs that you care about, which is why this is so much more powerful than just like ignoring sections or gamifying the application to be a certain way that you want it to be. Because whenever you do stuff like that, you're going to be opening yourself up to unexpected things, and you're kind of making too many assumptions on the application itself. So I hope that this was informative. Those are the 3 examples that I have for you today. I'd like to open it up to any more questions in the chat. I'm going to check to see. I see we don't have any questions in the Q&A section, which is totally fine. But I wanted to just take this time here to see if there's anybody else in the chat. If anyone wants to come up on stage and have a discussion, I can bring you up as well. We can chat about a question that you might have. But feel free to throw something in the chat if you're wanting to discuss something here. But if not, we can go ahead and wrap it up. So I'll just give everyone a minute here to think about any questions. And like I said earlier, this is being recorded, and we will send this out to everybody who has attended the session today, as well as those of us who registered but were not able to attend. So if you're leaving early, or how can we ignore if the skin color of the page keeps changing? So that's a great question. We have another algorithm similar to layout regions, which are specific to color changing. So let me share my screen once again and just show you this really quickly. So as we saw earlier, we have regions for layout, which are more geared towards like the content and validating the structure of the page. We have another algorithm called ignore colors region. And so ignore colors is something that will validate everything about an element. Like it'll validate the text, it'll validate the size, it'll validate everything else, but it will ignore any changes that are related to color. So like you said, like if this background of this page changed to white or blue or was different based on the time of day, you have some sort of dynamic content like that, you can use the ignore colors algorithm, which is, you could use it at the global level if you want to ignore all color changes, or you can use it as a region like we did with the layout algorithm. So you can do all sorts of these combinations. So like, let's imagine, like, so for example, take this situation right here. We have this element on the page called, or at the top that says your nearest branch closes in 30 minutes and 5 seconds. Now, this isn't live. This application that I built is not, this doesn't actually do anything, but we can imagine that this text right here might be black and not red if the time that the branch closes is not as imminent. Like right now it's closing in 30 minutes. Let's say it closes in 5 hours. That's not something that would warrant like an alert or like red text, right? And so if we don't really care about that color change, we can just simply do this and rapid ignore colors region around it. And so then if our baseline has the black text and our checkpoint has the red text, we're not going to get an unnecessary difference shown there. So I hope that answers your question. But yeah, so we do have solutions for color changing and all sorts of stuff. And again, these are all different types of tools that are available. You cannot overlap regions. So you can put like a layout region on top of an ignore colors region because the algorithm is not going to know what you're kind of going for there. The best thing you can do is use kind of like a combination throughout the page to understand. And layout region is usually the most like generic, and like anything that changes content wise will be ignored, and it doesn't really care what layout will also ignore color changes and things like that because it just, again, doesn't care about the content, doesn't care about the size of stuff. It just cares about the relative structure of the page. So to answer your question, can you overlap regions? Not necessarily, but there are overlaps between the algorithms that might fit your specific use case. Can you talk about when you need to do something on the UI and when you need to do something on the Cypress script? What's the source of truth of the rules to be applied? Could you clarify what you mean by that, Yanming? I'm not sure what you mean by like doing something on the UI versus something on the Cypress script. Are you talking about like drawing regions or like something in here versus doing it in the code? Is that what you're referring to here? Okay, gotcha. Yeah, okay. So the source of truth for the rules to be applied. So these regions are attached to the baseline. The baseline is, a combination of the screenshot that you're taking as well as the metadata, such as like the test name and the app name. And so when you apply a region to the test, you can see here I can save this, right? So I added this ignore colors region to this test result. And so now this ignore colors region will be present for all the times that I run this test going beyond. It doesn't matter if you add regions from the code or from the UI. Those both achieve the same thing in the sense that they're applied to the baseline and will be saved to the baseline going forward. What matters is that you don't necessarily, it just matters as a way of convenience. If it's easier for you to go into the UI and draw the regions around the specific sections, like for example, someone who's running visual AI tests against like a PDF, which we have support for, there's no selectors, right? There's no like CSS selector on a PDF that they can use to dynamically target a specific region of the page, right? And so they'd either have to draw it on the UI or they can like specify the exact coordinates in the code. Like, so another way that you can set the region that you're writing a region or that you're drawing a region around is rather than using a CSS selector, you can just put in coordinates like a width, a height, an X coordinate and a Y coordinate, and that will kind of define your region. So there's a lot of different ways, but they kind of achieve the same thing. And so the source of truth is the baseline. Whatever's on the baseline is the source of truth. If you write code that overlaps with a region that you've drawn, you're going to get something that overlaps, and you're not going to get the full functionality working correctly. So theoretically, you can overlap regions, but things are going to work, and things aren't going to work as expected. I hope that answers your question, Yanming. Christopher, algorithms deterministic? Yes, definitely. I mean, anything with AI, there's always a little bit of interpretation that occurs. We're all familiar with like ChatGPT, like where things can like change when you put in a different input. But in this sense, our AI algorithms have been trained to be like consistent. They've been trained to kind of like use the same kind of thought processes when analyzing images, use the same kind of thing. So like if we ran this test, without anything changing, like if these balances were all the same, right, and we ran it over and over again, you're never going to get a failure. You're never going to get anything that is different. Like if the inputs are the same, you're going to get the same output each time. And that's like the consistency that, we kind of hang our hat on, because one of the most annoying things is, as a QA engineer, is a flaky test. You don't want to have to spend time managing your tests. You want to just spend time testing your application and finding bugs. You don't want to deal with maintenance. So we really try to put a emphasis on that. And yeah, like the consistency is definitely very high with these algorithms. Yep, no problem. All right. Anything else that anybody would like me to go over? We do have a little bit more time, but no pressure if not. Okay. Hope still have one follow-up question. Yeah, go ahead. Yeah, I mean, lay it on me. Yeah, so okay, that's what so he says source of truth is the baseline. Do I need to draw the region for each baseline if I need to test different resolution and platforms for the same test? And that's a great question. And so that again leads me back to why I decided to create the regions for my baseline from the code, right? So when you create the regions for the baseline from the code, if we were to expand this to, let's just add in Chrome and Safari, right? If we were to add in and run more tests on different browsers with the Applitools Ultra Fast Grid, so we expanding, like you said, expanding to more resolutions, like we could change this to 1,000, whatever, right? We would need, if we wanted to draw them manually, we would need to go into each screenshot that we get and draw them manually. This is why I advocated at the beginning for putting that in the code, because this scales super nicely. Because as long as this selector exists, like maybe this selector doesn't exist on mobile environments, it's not going to fail your test. It's just not going to draw the region around it, right? So this scales super nicely for all the different environments, because when this selector exists on the page, it's going to draw a region around the bounds that correlate to that selector. And so regardless of if you scale up your tests to 100 different browsers, if you define your code in this manner, you're going to get a layout region around the selectors that you've defined, right? So that's why I advocated for doing it from the code, because it scales so much better. We do have things, something like we do have stuff called auto maintenance. Auto maintenance is like something that's designed for people who prefer to do stuff from the UI. So like if you wanted to draw this region in the UI, we do have something called auto maintenance, which will apply to other steps in scope. So you click this button, and imagine we had a bunch of other environments in this test batch that we ran. This would theoretically apply this region. It'll use AI to detect what this region is covering. So in this case, it's this string up here. It'll look for that string using like visual AI in all the other tests, and then apply that region to the other tests, right? You can do that, but it's always easier. We always think it's easier to apply it from the code, because then this becomes your source of truth right here. Like for this test that I'm running right now, our configuration says that we have 2 layout regions and 5 floating regions, right? So like this is the source of truth right here. We can define this, and at any point we could change it. We could say, get rid of that. I only want a region on 4 of the columns. I don't want a region on 5 of the columns, right? Otherwise, you'd have to go to the UI and delete them all. And again, we have auto maintenance to help deleting things, but you still have to perform the steps manually. In this sense, you have this infinitely scalable thing where you could scale it up to any sort of environment, and all these regions will be applied kind of as needed. All right, thank you, everyone. I think we'll go ahead and wrap up there. I think we're good. Thank you all. And like I said,